missed it. So, Mr. Anderson, we're going to do these last couple together. So excuse me for a moment while I finish putting up the work that you might have missed yesterday. Super, super, super quick. Of course, the graphs are up to you, but in case you didn't get this done, you can take a picture and you can get it done. Because class for 3.1, the stuff we've been doing all last week and so far this week is due today. The reason why it's due today is because I will have done every single question by hand together with you over these last couple weeks. So if that's not cause to hand something in, I don't know what is. So I'm going to work through this quickly because you should have seen this yesterday. If you didn't, then you'll be caught up. But we're going to do 7 and 8 together. Right now. Now, the thing that you might find really helpful is, because we will draw that line that kind of cuts it down the middle, we need a straight edge to do that. So I'm going to grab a ruler nearby. So, I like the shirt, Rosie. Thanks. My wife was at this festival. Really? Yep. Like I said, 310 Woodstock 99. My parents were more in the age of Woodstock 69, but they lived in the Midwest. What's up, Joe? It's good to see you, buddy. Got something for you. Do you need a copy of the one? Yeah, no, I have it. Okay, cool. So there's 5 and 6. If you have not done it, take a picture now or forever hold your peace because I'm about to erase it so we can do 7 and 8 together. And what I would love to have happen, if possible, is that we get to the point where we're feeling really, really good about this today, so that when I give you, I'm gonna hand you tomorrow's work before you get out of here today. That like once you get the hang of it, you can just get it done, and you'll see that like this 3.1 stuff is due today. 3.2 is not due until Friday. 6 questions. This one was 8. Next one will be 6. So it's really just kind of 2 questions a day. That's what I'm going to do. Today's what, Tuesday, right? I'm going to try to get all 6 questions done over the next 2 classes. I'll try to do 3 tomorrow and 3 on Thursday. And then I'll leave you to it on Friday on your own. We won't have to meet live or anything. Cool. The other thing that I think would be really, really helpful, if you do not own a graphing calculator, download one for free right now. This is by far the best graphing calculator emulator, the thing that looks like it, that I have found that's free. It's not everything the calculator can do. Like if you're taking AP stats next year, this is not going to cover. I looked at the stats folder because we were doing some stuff in stats in my prop stat class. So if you're in data decision prop stat next year, this would be perfect. If you're in college algebra next year, this would be perfect. If you're doing stat reason next year, this would be perfect. If you're graduating, even better, because I'm just giving you this opportunity to download something for free. Now, this is all one word, calculate 84. But I want to like talk you through the calculator because like creating your tables is so easy in the calculator. If you don't know how like the graph's supposed to look, press the graph button and there it is, and you can just kind of mimic that as the cool. So calculate 84. All right, let's do, what did I say, 7 and 8? Let's go. So turn to the back of that 3.1, very, very back. You're going to find number 7 and number 8. Let's work through it together. This is due tonight, yeah. Now, all the older ones that I've already done, those are all recorded and up on Canvas for you to check out. But if you have attended class, you have done all of them except for these 2. And you'll be good to x plus 2 cubed. All right, first things first, and I didn't write the instructions on 3.1. Like I said a couple times ago, I wanted to kind of keep the process a little bit close to the vest so you could learn it better, piece by piece. But when you see 3.2, it says, hey, make a table for your function, make a table for your inverse, sketch the graph in the line of symmetry, and let's find it algebraically. And so that's the order that I'm going to do it in. And I think it kind of goes from easiest to hardest. Simplest to most complicated, I guess might be even a better way to do it. And the calculator can do all this stuff for us. And so if you have that app, if you have a graphing calculator, open it up, take it out. And what we want to do is we want to give the calculator that equation at the top. So I'm going to jump in on my calculator, and I'll turn it towards you so you can see it. I'm going to share it with the folks at home so you can see that part too. But calculate 84. It's money. Okay, cool. So when you jump into your calculator, all the buttons at the top, those are all of your graphing specific buttons. And that's what we're going to eventually do. So that's a good place to start. Top left button, y equals. Okay. It should bring up something. Now, if yours still has an equation in it, like mine's empty right now, but if you have something in there because maybe you wrote it down from last class, you could press 2 different keys to make things disappear. If you press the delete button at the top, like right underneath zoom, that'll just delete one single thing at a time. A letter, a number, a symbol, whatever it is. You have to like delete, 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 delete. Or you can just press clear. Right-hand edge underneath the arrows, like towards the top, but underneath the arrows, there's a clear button that'll get rid of everything. And then you just type that in exactly as it is. Parentheses, which is above the 8, open them up. X, which is next to alpha. Towards the top, it's more than just X on that button. It says X, T, theta, and N, 4 different variables that we use, depending on what we're doing. Plus 2, that one's easy. Close parentheses, so above the 9. But then to the exponent of 3. Now there's an x squared button, like diagonal from the 7. That's for squaring things. I want to cube this. And so if you look at the division button, the one right above that is kind of like an up arrow looking thing. They call it a caret. That is a button that if you press that, it'll bump you up into the exponent. And it'll just wait for you to type whatever exponent you want. For us, that's a 3. So I just press the number 2.
Oh, that's right.
Yeah.
Mine has the caret and then there's that line.
So you have an older calculator, that's perfect. So it actually draws the caret and then puts a 3.
Yeah.
So what I'm about to say won't apply to you because as soon as you write the number, you are now out of your exponent.
Okay.
But for us, we're still stuck in the exponent, right? You see, like we're still blinking in the exponent. But what do you see blinking next to that 3? What is that? What does that kind of look like? If you did it on your, oh no, you probably can't, right? Yeah. Looks like an arrow. And that's a little hint that when you are done with your exponents, press the right arrow and it gets you out of the exponent. Because if you wanted to type like an exponent of 35 instead of just 3, then you'd have to actually do that. So for you, Colton, what you would have to do, you'd have to do caret and then parentheses and type in whatever exponent you want.
Oh, so I have to do the parentheses 3.
You don't have to if it's just a single number.
If it's like 23, then
I probably would just to be safe. Yeah. Now we can do a little +1. You right arrow out of the exponent, then you press +1. Now what I want is I want a table of values. And if you look at your graph, I only care about numbers between -10 and 10 because look at your left number and your right number, the bottom number and your top number. Those are -10 to 10, -10 to 10. So I want my table to look like that. And so before I actually press table, above the window button, again, buttons at the top are all graphing buttons. There's a window button, but like small letters, different color above that says TBL set, table set. So press second window. So the button like underneath the Y equals is the second button. It's kind of like a shift key or a function or a command or something that just kind of gets you up into a different set of buttons. Press second window and that'll take you to TBL set. And because my graph on the left starts at -10, that's where I want my table to start. at the top. Now, it might already be set up that way. Who knows? Maybe your table is set up to start at 0. Maybe your table, like mine, it happens to be at -2, because that's the last thing I was doing. I'm actually going to go ahead and type it in so it says -10. Now, careful here, though. There are 2 buttons that kind of look like negatives. The one next to the decimal along the bottom, that's actually negative. The one next to the 6, that's a minus for subtraction only. Okay, so be careful. We want the negatives. So you type in -10 for TBL start, and then remember what's that triangle? Do we know what that symbol actually comes from? That's not a triangle. It is a triangle, but it's actually a letter. It's not an English word. This is the Greek letter delta, and it stands for change. How much do I want my table to change every time I go down? 1 seems really nice, so it'll go -10, -9, -8, -7. It kind of skips all the decimals that I really don't care about. Because when I plot points, I just want really nice ones. And that's all we need. Independent set to auto, dependent set to auto, that'll be defaulted to that, so we never have to change that until we might later. We'll see. And now I can actually look at the table, which is second graph. So top right button, graph, we'll actually look at the picture, but second graph will give you the numbers. And again, remember the kind of numbers we want, right? -10 to 10. And so, yay, my x's start at -10, but what do my y's start at? -511. Not interested. If I can't plot it, I'm not going to bother writing it down. -10, -9, -8, all of those, no good until we get to -4, -7. Both numbers between -10 and 10. And you can include the -10s and the 10. Those are numbers because that's just like the edge of your graph. We can plot one there. That's cool. But that's where all of my nice points actually start. Like -5, -26 does not fit on this graph, so I don't include that. But -3, 0, sure, that looks good. -2, 1, yeah, I like that one. -1, 2, and I'm just copying down what the table is telling me. 0, 9, great, I love it. And as many points as there are that are nice, I'm just going to write those down. If I get a decimal, skip it. Number too big, too small, skip it. Only really nice numbers. Now, you want to be careful, like, ooh, I'm getting pretty close, so there might not be any more numbers after this. You want to know for sure. I want to check all the way to 10 to see if there's any other points that are worth plotting. And so that's where you press the down arrow to check to see what's happening with the rest of those numbers. And they're just getting bigger and bigger and bigger. So nothing I need to plot after 0, but it was worth checking in case it like loops back around or whatever. If we don't know what these graphs are going to look like necessarily, like I don't know what a cubic graph is off the top of my head, and that's okay. You want to just check the table all the way through from -10 to 10. But that's good. I'm happy right there. Are we good with the mechanics of that with the press? Now let's do the table for the inverse. Right next to it, side by side, nice and small. And what's nice is like I know exactly how many points are going to be in this table because I just put 5 sets of points in the function table, so the inverse one is going to have 5 points too. But before we even get to that, before we even get to like writing in the numbers, there's something missing from this table setup right now to indicate that this is the inverse. I know it's been a while. Does anybody remember? Dan? Yeah, and the thing about it is it's not like it's really neither of them. And so however you say it is fine, but it really just means the inverse. But exactly, a little -1, a little -1. This means the inverse of y, right? That's that inverse notation. Say, you know what? This is not just any xy table, but this is exactly the inverse of this. You always want to include that anytime we're saying, okay, here's the inverse that we got. How do we do it?
Maybe just flip it and flip the other one.
That's it. X is y and y is x. So all of my x's go in my y column. All of my y's go in my x. And I'm ready to get this thing graphed. Now, some people like to use one color, like their pencil for their function, and a different color for their inverse. You don't have to, but in case you want one, take a colored pencil. Pick one that's not relatively dark. You don't have to. You can say no, thank you. That's fine. Because you can just grab them both in pencil. That's fine. The thing I like about it is it helps me see really well which one's which. And if it's not quite as sharp as you might like, just sharpen over there. But if you don't want one, kindly say no, thank you. I like it. Yeah. All right, cool. I'm going to come back here and I'm going to get some things graphed. We're going to graph the function in one color. We'll graph the inverse in the other. I'm going to bring the camera so you can see it. Disconnect. Oh, come back. Bring you with me. Bring you with me as well. Let's do it. Now, here's the thing. Like, we're going to plot some points, and you might think you know what it looked like. You might be surprised. And so that's where I am going to heavily, again, rely on the fact that, you know what, this function is just sitting in my y equals in my calculator, and I can just graph. So I'm going to plot my points, and then I'm going to question what this thing is actually going to look like. Okay, -4, -7, sweet, put a point. -3, 0, awesome, put a point. -2, 1, -1, 2, and 0, 9. I pick the color, whether it's your pencil or something else, whatever. And I just plot the 5, the 6, the 12, however many points there are. This is just 5. And I pause for a second to make sure I don't mess up this sketch. Because to me, and just look back here real quick just so you can see it, like these 3 points right here look to be in a straight line. Okay? Press graph, like literally press the graph button on your calculator. Not second graph, but press graph. And what you're going to see is a graph that does not have any straight lines. Right? And we saw this last week, and I forget if we did it all together. But there's some curvature to this. Like I'm going to connect this bottom point, right? Where'd it go? -4, -7. This point to this one, but I do not go straight to that next point. I continue through it and then flatten out. Then I curve my way back up. Okay, it's called, and this is the technical mathematical term for it, it's called flexing. And if you take any college algebra next semester, next year, you'll see it. So it's good for us to see now. But I wouldn't have known that if I didn't press the graph button. Right? It has that flattening out that happens at those 3 points. And so I just connect the points like that. But knowing what I know about how many points I skipped in the table, I know that this is not the whole graph. There's a bunch of negative numbers and a bunch of positive numbers that were just too big. And so I have to make sure that I indicate that by going past that last point at the top and throwing an arrow on the edge. Just making sure I don't go to that next grid line. Same thing on the bottom. I'm going to keep going kind of down and out, right, towards the left edge. But I don't cross that next grid line because if there was supposed to be a point at -5, comma, whatever, I would have plotted it and I would have just ran into that line instead. But -5 was like -26, right? Wasn't it something crazy like that? Good memory. Yeah, -26. And so that number is like way down here, right? So we're not going to get to it. So we just extend it out and we're good. Good? Let's graph the universe. Switch colors if you want to. Now, the thing you want to remember, the order that we wrote them is the order that you plot them and the order that you connect them. Some graphs really won't make a difference. It'll be pretty obvious how to connect, but some of them are a little less obvious, so I try to repeat that sentiment as often as I can. So -7, -4. So left and right, and then up or down, right? Now, 0, -3. So that means, like, go to the origin and don't go left or right. 0. And then down 3. Okay? So just be careful. And then 1, -2, 2, -1, and 9. Remember, inverses are the opposite. And so we should see that symmetry. We should kind of blend it. So it's still going to have that flexing here. But remember, you connect the first point, the second, and you keep going. You cut through it. And then flatten out up. Keep going. Then like kind of edge your way to that point. And that can be tricky. The tricky part especially is that we don't have an equation for y equals yet for the inverse for us to plug into the calculator and look at. Now, we will in a second. And so you can always wait until we actually find the equation and then plug it in so you can see what it looks like. But lots of points here that we don't want to forget about, so we're going to extend it out. Just don't cross that next grid line at 1. Extend it out. Don't cross that next grid line down at -5. Love it. That sounds like me. Hello. All right. Now we have one last thing that we want to draw in here to show how symmetric everything is. We want to draw in that perfect line of symmetry. The one that's going to cut it right through the middle. Do you remember how to draw it, like where it goes? Where does it go? Perfect. Top right to bottom left. Perfect. A line that perfectly cuts through the middle of our graph. It's nice because I made this graph to be a square, so we can just do that. And I will always do that for you. This is exactly the space that you will be provided to graph in every time we do inverses, I promise. There it is. And what I love about that is just turn the thing sideways, put that line of symmetry up and down, and it looks so nice. Sweet. There it is. Now we can actually find the equation and see how well we did with our graph. Now I'm going to rewrite it. You probably don't have to, but I just like to work vertically straight down. No worries. Thank you. Where's my nice one? Oh, cool. Like I said, I'm going to rewrite it again. You don't have to. But I kept this process over here to make it easier for us to recall, because we really haven't done this in person since Tuesday. So it's been a week. And the first thing we want to make sure is that it's y equals and not f of x or g of x or h of x or whatever. Cool, it's ready to go. Every single time, what are we going to do? Every single time, we're going to make this. Y is x and x is y. Always the first thing to do. Make that. And then do whatever you need to get y by itself. Now, I like to write this over here just so we have something to look at. You don't have to write it, but you can if you want. Right? A reminder of how we solve for something that's kind of stuck, buried on one side. And it happens to be over here on the right because we made the switch. That's okay. We're going to do whatever we need to get y by itself. So what do you think? What should we do first? Start moving stuff away from the right side. Perfect. -1, because that's the simplest kind of level right here, right? Addition, subtraction. And what happens is the right side is going to get simpler. We're moving stuff away, so the +1's gone, so the only thing that's left is a y plus 2 cubed. And because the right side got simpler, the left side will get more complicated. It's going to get busier. Don't try to put stuff together and simplify. However you would read it vertically is how you're going to write it horizontally. X -1 Sounds good. X minus 1 it is. Addition, subtraction done. Now, if there was a number sitting in front here, like that wasn't a 1, right? That hidden 1 right there, we would divide it away. But it's just a 1, so we're good. We don't actually have anything being multiplied or divided, so onward. Now x1. And got that power of 3, so we got to get rid of it. And if that was like y plus 2 squared, great, we take a square root, because those are opposites. But this is y plus 2 cubed. So square root is not going to do it. What do we need? Cube root. Every exponent has its root. So I'm going to take not the square root of both sides, but the cube root of both sides. And usually when I do a step with exponents and roots, I just kind of like put them into the same line of work. If that drives you crazy, then take an extra line of work. How we have like equation step, and just come down here and do the cube root of both sides. If that is too frustrating, I totally. But I want to work a little faster, a little bit more efficiently. I'm just going to drop it right on. So that's up to you, however you want to write that. But we're getting better at this. I mean, heck, we're a week and a half away from the end of the third quarter. We know our stuff really well now, so that's awesome. And the whole point of doing that is so the cube is gone. The right side gets simpler. The cube and the cube root will always cancel each other out. So I'm just left with y plus 2. I don't even need the parentheses anymore because the cube was on the outside. It was the only thing on the outside, so the parentheses are gone. And again, don't try to like put stuff together or simplify. Whatever it is, just write it down. The cube root of x minus 1. Now, plus and minus is only for even roots. Remember that from Dash for a long, long time ago. Chapter 0, we talked about that. But this is an odd root. Number 3 is an odd number, so I don't need plus or minus. I am good with just the positive version, right? There's no number in front, like there's no symbol, so it's a positive root. So I'm happy there. Exponents and roots done, and now matching inside a grouping symbol, right? We got inside the parentheses, which was where the y plus 2 was buried, but now we've kind of broken it out. Sweet, let's do a minus 2 and get it done. You just can't put that minus 2 underneath, like with the negative 1. Can't do it. One's trapped underneath the cube root, one is not. So we just write it down. And if you want, like write it in the order that you would read it. The cube root of x minus 1. Make sure you stop your root. Leave some space, then put the minus. However you would read it out loud, write it down. That's what I love about this. Like it's just, oh man, it just flows really nice. You don't have to worry about going. And we're done. We got y equals. That's what I wanted, right? Solve for y. Sweet. The only thing I need is that inverse notation, right? Just like we put the little negative 1 on top for the y in the table, let's do it here too. And if it doesn't bother you, do it right now and call it done. If the fact that the y is on the right and everything else is on the left is okay in your mind, then just drop the little negative 1 and say, hey, I'm done. If it bothers you, make the switch. Put the y on the left, put everything else on the right. If I'm going to move stuff around, I better put them in a nice order. I'm going to put the negative 2 first and then the positive cube root. There's no negative here, so it's a positive root at the end. Either one's fine. If you want to make the switch, but you don't want to reorder it because you're afraid that you might screw it up, make a mistake and cost yourself a point that you did all this really good work, then don't make the switch. Just leave it. Like keep this order and put it right there. But that's the best way to do it. But they're the same. So. Now, let's check to see how we did. I'm going to jump back into my calculator, and I'm going to type this into y equals. We haven't done this yet, but I thought it'd be a good time to check it out because, gosh, that cube root thing, like, I don't really know how to graph that. So maybe you wait until you get to here. And so if you want, open up your calculator again. Keep your original function in y1. And if you want, jump down by pressing the down arrow into y2.
and type any version of that you want. I'm going to type my nice one, -2. So the button underneath the 3, -2 plus, and then, cube root. Like the square root's on the front. I don't know if you know where it is, but look for the x squared button on the left edge halfway down. That's x squared. If you press second x squared, that's a square root, but I want the cube root. What class are we in right now? What is this? Be less specific, be more general. Not just Algebra 2, but math. Find the math button. This is the most popular folder for stuff that's just not on the front. You can't find something, check the math folder first. Where is it, Colton? Right below alpha, MATH. Okay, this is a folder we've actually jumped into before. Look at that first option. It's not what we're going to do, but that very first choice, arrow frac. Change any decimal you want to a fraction as long as there's a fraction that goes with it. But number 1, I don't need right now. I need number 4. In this math folder, option number 4, cube root. Okay, older calculators will draw the cube root, and then it'll just open a parentheses. You type whatever you want, and then close it. Newer calculators, it'll just be blinking. Like it'll draw a cube root, and it's blinking, waiting for you to type stuff in. What do I want? I want x minus 1. Again, the x next to the alpha is the one we want. And now we want minus 1. And this is a really good chance to take a look. Look at the difference between your negative symbol and your minus symbol in the calculator. They're a different size and in a different place. Okay, now graph them both at the same time. If you needed it, now you've got a good guide to help you make that picture exactly. That's pretty good. Even blue and red, just like mine. The only thing that's going to be kind of frustrating, your graph is a square. Your screen is a rectangle. See how mine's kind of stretched out? Like it doesn't quite look like that. That might drive you crazy. I know it drives me crazy. And so as nice as it is to be in this window from -10 to 10, -10 to 10, I am stretching this square out to fit it in a rectangle. There's a way to fix that so you can really see a picture that looks like that. I told you all the buttons at the top are all graphing buttons. Pick the one in the middle. Press zoom. And see if you can find one that might be good for us to actually look at a square instead of a rectangle. Sounds good. Number 5, z squared. That's zoom square. And what it does is it actually just kind of like puts a couple more tick marks on your left and your right. It's actually taking you out to like -15 or -16 and then positive on the other side. But now it gives me at least a nice picture to look at. Now I feel really good about comparing this drawing to that one. That's just in case you need it. In case you say, you know what, I don't really know how to draw this thing. I'm going to jump in the calculator and let it do it for me. There we go. Number 7, done. Let's do 8. Does that come back to you a little bit now that we've done it again? Feeling all right? Okay. So I'm going to pick up the pace a little bit so we can be done, maybe even a few minutes early if we can knock this one out. But now you know how to do it. You don't have to wait for me. But you do have to know how to type in that square root. And I kind of alluded to it before. It's second x squared. But that's absolutely the very, very first thing I'm going to do is I'm going to jump into the calculator. I'm going to give it the equation. I'm going to share it home again just so you guys can see it. Voila. Jumping in the calculator. If you are not actually pressing the buttons yourself and just waiting for me to do it, you will not do well next week. We're gonna do quiz 3. Classwork 3.2. I'm gonna give it to you before you leave. That'll be the rest of this week. Monday, Tuesday next week we'll do quiz, like just effort and completion. Wednesday, Thursday we'll have time to knock out something for correct.
So on my calculator, I'm going to close the parentheses after the 8 when it comes up so I can square root it.
So did you do 2 parentheses? Sorry, 2 square root.
Yeah, but with the square root, then it's
open the parentheses. X plus 8. Close it.
Then minus 1.
Exactly, because where this square root ends is where your parentheses has to go. Absolutely, you got it. So for me, I got to do 2, and then to draw the square root, it is second x squared. X squared is up across the diagonal from 7 there. X plus 8. All right.
x plus 8 minus 4. And so you have to right arrow out after that plus 8. If you just keep typing minus 4, it's just going to put the minus 4 underneath, and we don't want that.
Why is that popping up?
The graph, you mean?
Yeah. I got a graph and it doesn't.
Nothing there.
Yeah. You should go back to minus 4.
Oh, let's go into it. Press the number 6 is standard. That's negative 10 to 10, negative 10.
Oh, that's why.
Bunch of weird decimals, right? So, right. No, minus 1. Now I got to set up my table so I get the same kind of setup that I want. I want to start at negative 10 again. And because I scrolled to look for nicer numbers, my table set actually has me right now at negative 11 because I was like bouncing all over the place. So I'm going to fix it. I'm going to go to negative 10 again. Delta table is always going to be 1. I don't have to worry about it. I'm going to make my x, y table. And look at what happens at negative 10 and negative 9. Why? Why? Like, why are we not getting a y value back when we plug in a number right here, like negative 10 and negative 9? Okay, but why? Why? You're absolutely right. Why? Because put a negative 10 right there. Add 8 to it. What do you get? It's negative 10 plus 8. Negative 2. We take the square root of negative numbers? No, like, answer this question. What number squared is negative 1? A number times itself is negative? No way. Positives times a positive is still positive. Negative times a negative goes back to being positive. You cannot have negatives underneath square roots. We're not going to get an answer back because it doesn't make any sense. And so, like, while all of these graphs have just gone on forever, right? Arrows on both ends. This graph actually has a beginning. And it starts when what's underneath the square root is 0. And negative 8 is where that begins. And so at a point like negative 8, negative 4 is a great place to begin. But negative 10, negative 9, and if you scroll up, it's just going to be error, error, error all the way through. Negative 8, negative 4 looks good. Negative 7, negative 2 looks good. But look at negative 6.
Can we just simplify it?
Don't even bother. If you get a decimal, skip it. Don't include it in your table, because how am I supposed to plot the point, make it 1.172 and do a really good job?
Negative 4.
Yeah. And here's the thing, like, watch this. You see how it only has like a couple decimals? If you actually arrow over to that number, look at the number across the bottom. It is way longer than that. It's one of those weird square roots, right? Those numbers that kind of go on forever. That's the square root of, let's see, drop a negative 6 in there. That's the square root of 2.
Where do you stop at? You just stop at like negative 4 and 0, and then there's a 1 and a 2. You stop at the 1.
You always want to check all the numbers between negative 10 and 10 because that's the space that my graph has. So I'm going to skip all the decimals. So negative 3, negative 2, negative 1, 0. Ooh, 1's good. 1 comma 2 looks good.
And then 8 and 4.
And that's it, right? 8 comma 4 because 9 and 10 have decimals. And I'm done. When you create your table, do it with a purpose, right? Write down points that are nice to plot. Because, yeah, all those decimals are going to be there when I connect it nice and smoothly. And I don't have to stress about trying to hit all those spots. Now, if you want to write them all down, go for it. But really, I only need nice numbers. Sweet, there's our table. Let's make the table for the inverse. Again, what am I missing? What do I need to show that it's the inverse? Very good. And how do we make that table super, super fast? Flip it. Yeah. All your x's are y's. All your y's are your x's. All my x's live in the x's. There we go. There's my function and its inverse. Let's graph this thing. That's not true. All my x's live in New York. That's why I left. I brought the good one with me. All right, sweet. Pick a color, plot your function. Now here's the thing. You might want to press graph. just to kind of like give you the clue, like, you know what, this does not go on forever to the left and the right. The reason why all of those negative numbers, like -9 and 10, and if you went up, you'd see even more, all of those give us errors, and you can see that when I graph this thing, I'm going to zoom stand so I get back to that window, like there's a beginning. This graph has a beginning to it, right? It does not go to the left edge. Oh man. Press zoom. There you go. Right, that graph has a beginning. And so do not feel like you're ever doing any of these things on your own. Press graph, you will be able to see exactly the kind of picture you're looking for. -8, -4, -2. Again, not straight here. The only thing we're ever going to need to draw straight lines is that line of symmetry. And if we actually just had a line as a whole, right? If you plot all the points and they go nice and straight, then that's good. So I'm going to connect smoothly, carefully. Those 5 points. But do not extend it on the left. That function doesn't have a left. It does have a right. The way that I can tell is that when you actually press graph, your graph runs into the edge of the screen. If your picture on your calculator hits the edge of that rectangular screen, put an arrow. Whether it's the left side, right side, top, bottom, whatever, that's where an arrow is going to go. And if my function didn't have a left side arrow, then my inverse won't. -4, -8, I'm going to plot the next one. All my x and y's make the switch. Again, if you're not sure exactly how to connect these and you want to make sure you're doing it right, we can wait until you get the actual equation. You can like plug it in, see what it looks like. But when all else fails, be smooth. Okay. Right? So again, there's no left side, but we're going to spin the right side. And we'll go. So. Cool. So what we'll do is we're going to take this same exact cell, take all those numbers to the bottom. Not to worry about it. Take those numbers, and then you're going to say, all right, I need to figure it down. Well, 0.5. That's like almost 5. Be like, remember how like we just like drop that line down to kind of estimate where that's at? We're going to drop that down. So all those numbers at the bottom will be on top. What are you doing? It's going to be the same number. Drop that. Oh, where's 3 at? Here? Stop.
Yeah.
Stop. 3 minus the mean over the deviation. Remember that score tells us how good or how bad was or how good. Yep. And we'll have the time next class to do all that stuff too. Like we can knock out those last 3 pages for sure all together. All right, don't forget your line of symmetry. Top right, bottom left. And then let's knock out the equation and we'll be done. Thanks, JC. Come in there. Yeah, top right, bottom left, and it should just cut right through. And if your function and your inverse cross somewhere, that line of symmetry should cross right there. It's going to cut right through. All right, let's do it. Let's finish her up. Yeah. All right, so I'm going to write it again. You don't have to, but we'll definitely take that first step every single time. Switch X1. All right, so let's talk through it. What do you think we should do first? Gotta get y by itself. It's trapped on that right side. Sounds good. Any addition, subtraction that is kind of stuck, sitting by itself, a little +4, a little +4. Right side gets simpler. However you would read the left side, just write it down. X + 4. Now what? Like over here, we didn't have to worry about multiplying or dividing because this was just a 1, right? We didn't have to divide away some number sitting at right after the equal sign. What should we divide by? What number is being multiplied through? Well, oh. Now, so look at the difference between like when I put a number in the root spot, like small, like up at the top, like kind of in the nook, versus nice and big right out front. Don't let that confuse you. Like, is that number being multiplied through, or is that just my root? It's going to be nice and big, or it's going to be nice and small, and that's fine. Cool. So right side got simpler, and whatever you have on the left, just write it. X + 4 over 2. Square root y + 8. Done. Okay. So if there's already a square root there, I don't want a square root again. That's me doing twice the square root. I want to do the opposite. What's the opposite of square rooting something? Yeah. So if I want to get rid of that root, don't just like put another one over here. I see that all the time. Like there's already a root and people are like, oh, I just got to put a root over here. I got to do the opposite. I have to take this whole right side and square it. If I'm doing that to the right, I better do it to the left. Now, the only point of me doing that to the right was so the square root would go away. So y + 8 is what I got left on. And again, whatever the left side looks like, just bring it down. Whatever you did, just bring it with you. Exponents and roots done. Now we're inside that grouping symbol, and yeah, that square root was grouping the y and the +8 together. But now I kind of broke it out, and I finally can get inside, and I can deal with the +8. Of course, we know what we're going to do. We're going to do the opposite, a little -8, -8. But don't try to like put that -8 inside the square, inside those parentheses. Right? Stop trying to combine stuff together with inverses. Keep your life simple. However you would read it vertically, let's write it horizontally. X + 4 over 2 squared minus. And if you are okay, drop a little -1 above your y because you're done, or make the switch. X + 4 over 2 squared minus 8. Don't leave until I give you 3.2, which is what we'll start tomorrow, and we will definitely have some time Thursday to get done.
Hold on. Hey, Rosie.
Yeah.
I don't know if you heard me the first time I said it, but
I
I
did
was
not.
just like, okay, so I was like I am cohort B, but I stayed in the class like online because I had to go pick up some stuff from my house. But I was like here the whole time, just so you know.
Okay, thank you.
Okay, of course, thank you.
Thanks, Sam. All right, have a good day, everybody. I will see you virtually mañana, or if you're cohort A, I'll see you in person, and then